Hello, welcome to the video solution for past paper. This is Edexcel IAL Physics sample assessment paper for new specification. So let's start. Question number 1, quantities can be scalar or vectors. Select the row of the table that correctly states a scalar quantity and a vector quantity. Again, the typical question comes in MCQs, these types of question, that they ask you to identify scalar and vector quantities. So if you memorize all the scalar and the vector quantities, so it will be easy to give answer for this type of question. And I'll just give you a table. If you see here, so all these quantities are scalar, like speed, mass, length, temperature, distance, volume, area, extension, work, power. These are a scalar, and all these are vector. And then now you can see here, the first is a scalar column and the second one is a vector column. So mass is a scalar and momentum is a vector quantity indeed. So option should be A. Because B, momentum is given a scalar, which is wrong. In option C, mass is given in a vector, it is wrong. And for D, weight is given in the wrong column, scalar. Weight is a vector quantity. So your option is A. As lava leaves a volcano, it cools down. Select the row of the table that correctly describe the effect of a lower temperature on the viscosity and the rate of flow. So temperature and the viscosity. So you say that the viscosity is inversely proportional to the temperature. So if temperature is decreasing, lowering temperature is decreasing, so viscosity should be increasing. This is a symbol for coefficient of viscosity or viscosity. So viscosity increasing. And when viscosity increase, viscosity is a hindrance in flow, resistance in flow. So flow is going to decreased. So viscosity is going to increase, so cannot waste time on B, either C or D, and the flow is decreased, so option is D. A car is traveling at a velocity v. The driver applies the brakes and the car decelerates until it comes to rest. The work done by the brakes on the car is W. Which of the following expression is correct? W proportional to work, W proportional to V square, and so on. Remember, when drivers applies brake and the car already had some velocity V, and then the brake does work against the energy. So work done by the brake, so work done by the brakes is equal to kinetic energy. So clearly W is equal to, because there's nothing to do with the masses, all are relation with the work done and the velocities. In kinetic energy we have V square. So the work done equal to half mv square, that means W and V square. So your option is B. Actually this expression is saying that how much work is done by the brake in order to stop the car. So it depends on square of the velocity other than mass. A man applies a force F to a box and the box accelerates. The forces acting on the box are shown on the diagram. Weight, contact force, friction, and the F. This F is the force of the man on the box. According to Newton's third law, the box will exert a force on the man. Indeed, because Newton's third law, every action has an equal and opposite reaction. So the box will exert force on the man. So the box should apply force on the man. It should be equal in magnitude as that of the force, but it should be in opposite direction. So select the row of the table correctly describe magnitude and the direction of the box of the force of the box on the man. So magnitude should be, of course, F, either A or B, both are correct. So C and D are gone. And what should be the direction? It cannot be direction as the original one, so it should be opposite in direction. So the opposite direction of F is the friction. So the direction of the Newton third law pair of force should be in the direction of the friction. So your option is B. The photograph shows the flow of air around the wing of an airplane. So this is an airplane. Okay, two positions are given, X and Y. Remember this X, these lines are laminar flow and Y is turbulent flow. So X and Y are 2 points in the path of the airflow. Which of the following statement about the speed of the air is correct? So the speed of the air is x-axis. So we need to understand speed of air at x. So the speed of air at x is constant. Indeed, it should be the option because we need to find the correct one. So it should be our option because at x we have laminar flow, and laminar flow, the speed of air at every layer is the constant. So they move with a constant speed. So our answer should be A. But let's see by rest of the option. B, the speed of the air x is continuously changing. No, because the laminar speed constant. The speed of the air at x is equal to the speed of the air at y. No, it cannot be changed because of y we have abrupt change. So velocity of at y continuously keep changing of every layer, every position. The speed of the wire of the air at y is constant. Indeed, only A is the correct option. Question number 6. A ball is dropped from a window and takes 1.6 seconds to reach the ground. Which of the following is height of the window? A straightforward question. Ball is dropped and falling freely. So S is equal to UT plus half AT squared, and U is 0 because it is dropped. So height covered or distance traveled is equal to half of G is 9.81 times T square 1.6 squared. Once you solve this, so you have answer 12.556. Round it off because it is not given in decimal, so round it off till 13. So your option should be B. Question 7 and 8 refers to the following informations. Increasing force were applied across the end of a wire and corresponding extensions recorded. A force extension graph was plotted for the wire, force and extension. The point marked X is the elastic limit of the wire. Which of the following statement is not correct? So this is the elastic limit. Fc is the maximum force at which the wire behaves elastically. Indeed, because this is elastic limit, so it is behaving elastically, and after that the material will be permanently deformed because this is elastic limit. Fc is the maximum force at which the wires obeys Hooke's law. No, of course, our option should be B because we need to find the statement which is not correct, and the statement B is saying that the Fc is the force which is at which wires obeying Hooke's law. You see, we don't have a straight line. So if we don't have a straight line, how can we say that it is obeying Hooke's law? So it is not obeying Hooke's law. This is wrong statement. So our option is B. And rest of the option, Fc is the minimum force at which the wire permanently deforms. Indeed, if at this point it will be permanently deformed, the minimum force at which the wire behaves plastically. Of course, this is also correct. So all the three A, C, and D are correct. Only B is wrong. Increasing forces were applied across. Okay, same question, but the force on the wire was then decreased and then corresponding extension recorded. The values were plotted on the same axes. Which of the following is the correct graph? So remember, when a permanently deformed wire or some object, when force is removed, so there were a slight decrease, a very slight decrease in the extension, but it will not reach to the original shape. So if you see the option B, which cannot be our option, and option D, option B and D, they are showing that material is returning to the original shape. You see here, material is returning to original shape, and the material has permanently deformed, so it cannot return to the original shape. So we cannot have option B and D. There is a slight difference between A and D. A is saying that when you decrease the force, there will be no decrease in the extension. This does not happen, because when you decrease the force, there will be a slight decrease in the extension, but not the original shape. So once you draw unloading graph of permanently deformed object, so you can something like this. So this is the unloading. So your option should be C. Question 9 and 10 refer to following information. A student carries out a practical to determine the viscosity eta of a liquid. A small metal sphere of radius r is dropped into a cylinder of the liquid. A cylinder, 4 different positions are marked. Elastic bands are placed around the cylinder in the position 1, 2, 3, and 4. As shown, the time taken for the sphere to fall between two of the elastic bands is going to be recorded. Which of the following are the best elastic bands to use? Remember, this type of question, most typical question of viscosity and terminal velocity. It's all accuracy or all depends on the measurement of velocity, or especially the terminal velocity. So what happened when you drop a sphere initially? So initially, you know that there is unbalanced force X, and the sphere is continuously accelerating, and after some times forces are balanced, and then sphere starts moving with the constant velocity. So when we talk about the terminal velocity, we take the interval after a while. Definitely 1 and 2 are not best option, best choice. 2 or 3 might be, depends on the viscosity, but in general we say lower the depth you take, so more chances of having the terminal velocity. So our option is 3 and 4, because it is possible that in 2 and 3 sphere might accelerating we still have. So which one is the best two elastic bands? So it's 3 and 4. Because 2 and 4 cannot be. The reason is because 2 is at the approximately at the start. So 2, here we might have unbalanced force. So best option is 3 and 4. The sphere is made from a metal of density rho m, and the liquid has density rho L. Which of the following expression correctly gives forces acting on the sphere when traveling at a terminal velocity? So at terminal velocity, you know that all forces are balanced, and when this sphere is falling down with terminal velocity, you know that there are 3 forces acting on this sphere. So this sphere falling down with terminal velocity experiencing weight acting downward, upthrust acting upward, and drag force also acting upward. But at terminal velocity, all forces are balanced. So you say that d plus u should be equal to w. This is a general relation between the forces at terminal velocity. But in our option, they are saying in all option at right hand side we have 0. So send w on the other side. So d plus u minus w equal to 0. And then the first equation, now you see 6 pi eta rv, all these are drag. This is correct one. So the upthrust should be positive, and in this case, see upthrust. So this rho L is showing that these all are same rho L. That means this middle term is upthrust, but upthrust should be positive. That means we cannot have option B. and C. Here upthrust is giving, negative. And the last term should be weight, and weight should be negative. So it cannot be, because it is positive. This is the right option. So D plus U minus W equal to 0. So our option is D. Question number 11. A student carried out an experiment to determine the Young modulus of a material in the form of a wire. The student set up the apparatus as shown. A typical experiment of Young modulus, I guess most of you have done in your school. A wire is placed horizontal on the table, hanging mass, and the meter rule to measure the extension. The initial length of the wire was measured. Slotted weights of known values were added to the hanger at the free end of the wire. Each time a weight was added, the new position of the marker was recorded or read from the ruler and extension calculated. Describe graphical method that the student should use to obtain a value for the Young modulus. State the additional measurement that would have to be taken. Okay, so if you see, they have said that we have initial length and we are adding additional weight. So we are measuring hanging mass, and then new position was read. That means extensions are also mentioned here. What is not mentioned is the area, because you know that the Young modulus is stress upon stress, stress upon strain, stress upon strain, and stress is force per unit area. And this force we can find from the hanging weight W, and this extension or this strain is delta L over L. So delta L is the extension and length L is the original length which is measured. So only thing that we need in Young modulus, area. That means for area, first a student should measure the diameter, and using this diameter a student can find the area by pi d square by 4. And then there are two options. The one that I think that easy is this approach, stress upon strain. So after measuring the diameter and the area, the student should convert weight into find the weight, of course, and then find the stress. From the weight he should find a stress for each single added value of the weight. So find the stress and then strain of each reading. Once the student has a stress and a strain, he or she can draw a graph of stress against strain, and of course it should be a straight line passing through origin, and the gradient of this straight line should be the Young modulus. So that's what you can explain everything in your answer, and you can write like this. Two trolleys A and B are placed on a smooth track so that they are touching. When a peg is tapped on a trolley A spring inside trolley A is released and the trolleys move apart. So this is a system. Trolleys initially are at rest. When the peg is tapped, there is a spring inside trolley A and it is stretched or released. So both the trolley moves away from each other. Explain why the two trolleys moves apart when the spring is released. Clearly, it's all about Newton laws. When a spring is released, the spring apply force on the trolley B. So a spring is applying force on the trolley B. So according to Newton's third law, the trolley B will apply force on trolley A, action reaction. That's why both of the trolley moves apart. Explain which trolley will move off with a greater speed. You know that initial momentum is zero. So, because it's all about explosion, it is an example of explosion in which initially particle is at rest. So initial momentum is zero, and the momentum of trolley A, which is trolley A, it will be moving leftward, it will be moving rightward. So rightward direction I'm taking positive, and left direction I'm taking negative direction, and this is positive direction. So the after explosion, or after tapping the peg, the momentum of trolley A plus momentum of trolley B will be sum of these two will be zero. So minus of MA VA plus MB VB. So this is law of conservation of momentum. That means MA VA must be equal to, this implies that, MB VB. And since mass of the trolley, if you see, mass of the trolley A is less than mass of the trolley B. So it is, this equation only holds if VA is greater than VB, because trolley A is lighter, so the momentum should be equal if trolley A will be moving faster. So speed of trolley A will be higher than the trolley B. Question number 13. Child P throws a ball towards a child Q at a speed of 20 meters per second at an angle of 75 degree to the horizontal. While this ball is in the air, child P throws a second ball also at the speed of 20 at an angle of 15 to the horizontal. Both balls reach child Q at the same time. Determine how long the child P should wait before throwing the second ball. We need to find the time difference between the first and the second throw. So we have different approaches to find the time difference. One is because they are, both balls are covering same distance, so we can use S is equal to UT distance in terms of T1 and T2, because this is same, and then we can compare. But the best option other than horizontal one is we use the vertical motion. And you know, the vertical motion for a projectile is accelerated motion, and we will be considering the whole motion of the ball from projection till catching situation, or when the ball is caught. So if you see the displacement of the ball at initial and the final position, so displacement S should be taken as 0. That's approach we are going to use, and because it's a vertical motion, so let's for B1 we say that the time is T1. So this is the time for T1. You can mention here, T2 is there. So for B1 I'm using S is equal to UT plus half AT square, and remember we are using vertical motion, so this U should be a vertical component or initial vertical component of the velocity of the ball, or in general projectile, meaning this U should not be 20, this U should be 20 sine 75 for ball B1. So this S is the displacement, which is 0 for ball B1 from initial and the final displacement 0. U is 20 sine 75, and time I assume that it took T1 plus half AT squared, so half AA is minus 9.8. Remember, when we consider in a projectile whole motion, so G is always negative. So minus 9.81 and T1 squared. Clearly you see that if you find 20 sine 75, your answer will be 19.3. So for that 20 sine 75, it is 19.3. Now you have a quadratic equation in terms of T1. You can solve this equation for T1. And how do you do that? You can rearrange this equation in the form of quadratic. So once you rearrange this, you would have a 4.91 T1 squared and minus 19.3 T1 is equal to 0. Don't need to use a quadratic formula. You can factorize because you don't have constant terms. So take T1 common. T1 is common. So you have 4.91 T1 minus 19.3. Clearly, one value of T1 from here is 0 for that T1 and the other T1. So you have T1 would be equal to 19.3 divided by 4.91, which is equal to 3.9348. 3.9348 and 3.94 second. So this is second. So this is T1, and if you apply same approach for ball B2, so for B2 you have 0 into, for B2 you have a horizontal velocity is 20 sine 15, and then time is T2 minus half into 9.81 T2 squared. So finally you would have a equation of T2 will be 4.91 T2 squared minus 5.2 into T2. This 5.22 is basically the value of 20 sine 15. So T2 square, T2 square is there, is equal to 0. Again you have a T2, one value of T2 will be 0 and the other value of T2 would be 5.2 divided by 4.91, and it will give you 1.06 second. So delta T, the time difference, delta T is T1 minus T2. So delta T is 2.88 second or 2.9 second. This is change in difference between the time interval. So a student should wait for 2.9 second and then throw the second ball. The significance of these T1 equal to 0 and T2 equal to 0 is that these are the timing when the ball is at a start point of projection, and the second time when the ball reaches at the other end. So these are the timing when the ball is reaching at the other end. Question number 14. A musical instrument called triangle consists of a metal bar bent into a triangular shape. The triangle is open at one corner. A full-size diagram of a triangle is shown below. The position of center of gravity has been added. Part 1 or part A, state what is meant by center of gravity. A typical question of center of gravity definition: the position or the point at which weight of the object, weight of the body appears to act. So this is one definition of center of gravity. You can write. Part B, determine the moment of the weight of the triangle about O. You need to find the moment. So you know that the moment you can find is force into moment arm, or the pivot distance, or perpendicular distance. And in this case, this F will be taken as W, which is equal to mg. So the F is not a problem because mass is given. So we can have F. But the problem is D. How can you figure out this value of D? That's why they gave you a reference of actual size. So whenever they give you actual size, that means you need to do something with the figure given, meaning you need to take measurement from the picture and then use this measurement to solve the problem whatever being asked. So here if you see what is the situation, the weight of the triangle acting center of gravity, and it will be acting vertically down. So this is the direction of the weight, and this is the pivot, you know. And if you join pivot with the point of action of the force, so you see that it doesn't mean that this blue line will be showing, the distance d. It is not a d. This is not d. D is a perpendicular distance. So how can you visualize the perpendicular distance? You just, extend backward the weight in a backward direction vertically, and you see that. So from the pivot and the line of action of the force, so this is called pivot distance. You need to measure that distance. So use your ruler to measure this distance, because I cannot do here. So in your paper you can do it. So this is pivot distance. So you can measure from here, or you can do in a way that you can draw a perpendicular line from O, and that distance will be as same as this one. So this is also D. So use these D here, and then you can find the moment of the force or the weight. The triangle is now suspended by a thread from O. Explain why the triangle settles in a position where the base is no longer horizontal. Initially, you can imagine that if you hang this triangle at point O at that moment, right now, when center of gravity is here, so this center of gravity is slightly towards the right side on the from the pivot. That means this center of gravity is going to produce a clockwise moment, due to which the triangle is going to rotate clockwise. And then you will find that the triangle will be something like, here, and then something like this. So that will be the new position of the triangle, there where the horizontal base will remain, does not remains horizontal. The reason is, when the triangle produce moment, this center of gravity shift leftward, so that the center of gravity will exactly under the pivot, and there will be no d, there will be no moment arm, d will be 0. So if d is 0, that means there will be no net moment, so the triangle remains as it is once it is settles down. So center of gravity shifts leftward, center of gravity is directly under pivot, so line of action is passing from the pivot, so no net moment. Thank you very much. I hope you understand. See you in the next video. Have a nice time.